Solar fuels are a gateway to a cleaner, greener, and safer future in energy. Generated by harvesting sunlight to produce liquid or gaseous fuels, they can be used in the most versatile ways, powering our vehicles on land, sea, and air, heating and cooling our buildings, and fueling an array of industrial processes. Solar fuels could play a key role in decarbonizing our energy systems in those different sectors. In this context, the European Union has joined Mission Innovation with the aim to accelerate innovation in clean energy technologies and to look at the potential of solar fuels worldwide as part of the Union's overarching pledge to decarbonize its society and economy by 2050. Considering solar fuels as a potential game changer, the European Commission, as co-chair of the Converting Sunlight Innovation Challenge, procured a qualitative and quantitative assessment of solar fuel value chains worldwide.
While fossil electricity can easily be replaced by renewable electricity, the replacement of fossil fuels is something which is much more challenging. Solar fuels can really represent a very promising solution to this problem. Anyhow, significant developments are needed in order to make them market ready. Therefore, the European Commission selected EY in consortium with EMEC, RINA and SEPS to assess technological and economic roadmaps to bring the solar fuels to markets in the next decades.
Solar fuels are synthetic fuels produced from using sunlight energy to drive chemical reactions, ultimately resulting in the production of a fuel such as hydrogen. Solar fuels are used just like fossil fuels to fuel our vehicles, heat and cool our buildings, power industrial processes, and they can also be used as a means of energy storage to essentially mitigate the seasonal variability in renewable energy production. Solar fuels have a low carbon footprint, so they could really be a key component in decarbonization efforts worldwide. And now, as we're seeing the cost of solar power declining, we can actually foresee a future where solar fuels could become cost competitive with comparable fossil fuels.
Solar fuels are produced in different technology routes. They are based on different pathways, electrochemical, thermochemical and biochemical. The most advanced technology route is a two-step process actually, where cheap electricity is produced by solar panels, and this electricity is then used for electrolyzers to split water and produce hydrogen. Very promising technologies are the photo-electrochemical conversion from sunlight and water into hydrogen, and thermochemical electrolysis where heat is used to split water, actually steam, into hydrogen.
The key bottlenecks to solar fuel development consist both in technological challenges and economic constraints. To overcome these challenges, further research is required, with a specific target of lowering resource consumption and the overall production costs. Moreover, circular economy concepts, as well as co-production of different products, especially added value compounds other than fuels, can increase the sustainability and economic feasibility of solar fuel value chains. This is the case, for example, of biofuel production from microalgae.
Our assessment is that the most mature solar fuel technologies could become market competitive as early as 2035 in some regions, depending on the level of public investment and support. Solar fuels are expected to contribute to approximately 4% of our energy needs in 2050 in an average scenario, and up to 6% in 2100. They're expected to contribute most to the transportation sector, and in particular to maritime and aviation transport, and as well to industry and buildings, of course.
Significant investments are needed for the deployment of solar fuel technologies in order to develop the capacity required for them to play a significant role in our energy systems. These investments will spur the synergistic growth of solar fuel value chains, including additional solar farms to power solar fuel production. Significant investments in R&D, as well as a strong carbon price, would spur the development of solar fuel value chains worldwide, where nearly market-ready technologies are already playing a role today. These developments will require concerted efforts from stakeholders in energy supply chains, policymakers, and consumers.